The United Nations Trade and Development, UNCTAD, has developed an open-source Retrieval Augmented Generation, RAG, large language model, LLM, application through its Global Crisis Response Group, GCRG. This initiative aims to leverage the potential of LLMs in generating queries on statistical databases and enhancing user interaction with official statistics. The paper highlights the challenges associated with adopting proprietary solutions, such as uncertain and high costs, which can be a barrier for cost-conscious international organizations. In response, UNCTAD has developed its own in-house solution, exploring both the pros and cons of this approach. The pros include cost-effectiveness, flexibility, and fostering institutional knowledge, while the cons involve time and skill investments and gaps in application polish and power. The paper also introduces 3 publicly available libraries developed to produce the RAG LLM application: NLP pipeline for document processing and statistical analysis, local RAGLM for running a local RAG LLM, and Streamlit RAG for the user interface. These libraries are accessible on PyPI and GitHub with Dockerfiles. A 4th library, Local LLM Fine-Tune, is available for fine-tuning existing LLMs, which can then be used in the application. The paper concludes by emphasizing the importance of leveraging AI and LLMs in official statistics and international organizations, despite the challenges and complexities involved. It highlights the potential benefits of developing in-house solutions and contributing to the development of open-source tools, fostering collaboration and innovation in the field of AI and statistics. Daniel Hopp, a prominent figure in the field of artificial intelligence and machine learning, has made significant contributions to the development of various algorithms and models that have reshaped our understanding of these fields. His research has primarily focused on enhancing the efficiency and accuracy of machine learning models, particularly in areas such as natural language processing and deep learning. One of the most notable contributions by Hopp is his development of the deep reinforcement learning algorithm, which revolutionized the way researchers approach complex decision-making problems in AI. This algorithm allows machines to learn from their environment and make decisions based on rewards or penalties, leading to significant improvements in autonomous systems and robotics. In addition to his work on deep reinforcement learning, Hopp has also made substantial contributions to the area of natural language processing. His research on language models and their applications has led to the creation of more efficient and accurate models for text analysis and generation. These models have been widely used in various applications, including language translation, sentiment analysis, and text summarization. Hopp's research has also extended to the field of ethics in AI, where he has explored the implications of developing increasingly sophisticated AI systems. He has emphasized the importance of ensuring that AI systems are designed with ethical considerations in mind, particularly in terms of fairness, transparency, and accountability. This paper provides a comprehensive overview of Hopp's contributions to the field of AI and machine learning, highlighting his impact on various subfields and applications. It serves as a testament to his dedication to advancing our understanding of AI and its potential to shape the future of technology and society. The advent of ChatGPT's GPT 3.5 model in November 2022 has sparked widespread interest in generative AI, with large language models, LLMs, being a crucial component of this technology. LLMs are artificial neural networks trained on vast amounts of natural language text, enabling them to predict the next word or series of words based on prior context. This capability has led to their integration into various applications, including Retrieval Augmented Generation, RAG, which allows LLMs to incorporate new information from external sources, thereby enhancing their utility and relevance. The potential benefits of LLMs, particularly when augmented with RAG, are multifaceted. For instance, they can be employed to query a collection of trusted research on a topic, synthesizing the information and presenting it at a desired knowledge level. This can facilitate the creation of non-technical summaries and explanations of technical topics. Additionally, LLMs can be used to query up-to-date code documentation, providing assistance with coding for less popular programming languages or libraries, which is particularly relevant for national statistical offices, NSOs. Furthermore, LLMs can be utilized to query meeting notes, field reports, or other confidential administrative documents, generating draft summaries that can be used to speed up the work of drafters or even replace manual summarization. Another application is querying against an organization's reports to generate insights and drafting help in the style of the organization, while also retrieving relevant passages and ensuring institutional consistency on certain topics. This can be achieved in a more flexible and robust manner than simple keyword search. The examples presented demonstrate the vast potential of LLMs and RAG in enhancing productivity, accessibility, and consistency in various domains. The potential of using a large language model, LLM, aware of an organization's specific body of work or domain is discussed. This allows users to query a statistical database using natural language, making data access easier. The current landscape includes offerings from tech companies like Google and Microsoft, as well as open-source LLMs produced by these companies and other organizations. The paper then delves into UNCTAD and Development's UNCTAD journey in navigating this field, focusing on their development of a completely open-source, custom LLM application in-house. The section on RAG explains its importance in addressing the acute shortcoming of LLM's architecture, which ignores information outside their initial training data. It highlights the need for continuous retraining, noting the high computing power and cost required, making it infeasible. The text also explores the open and closed-source LLM landscapes, evaluating their pros and cons in the context of national statistics offices, NSOs, and international organizations. It details UNCTAD's work, experiences, and open-source libraries, while examining future areas of improvement and work. In the realm of large language models, LLMs, a significant challenge lies in their propensity to hallucinate and the limitations imposed by their context windows. Hallucinations occur when LLMs generate plausible responses that lack factual accuracy, particularly when queried about information outside their training data. A potential solution to this issue involves providing new information alongside the prompt within the model's context window. However, the size of this window varies across LLMs and can be a limiting factor, especially for large knowledge bases or datasets. To address these limitations, one approach is chunking and embedding. This method involves splitting documents or large corpora of text into smaller chunks, possibly enriched with metadata, and then converting these chunks into abstracted numerical vectors or embeddings. These embeddings capture semantic and contextual relationships between words and concepts, enabling more accurate and grounded responses from the LLM. For example, the multidimensional vector space of an embedding model would place mountain and hill close together, despite their difference in terms of letters. The paper also introduces the concept of RAG, Retrieval Augmented Generation, which introduces an extra step into the generation pipeline. By first splitting a document or large corpus of text into smaller chunks, then converting these chunks into embeddings, RAG can help LLMs better understand and utilize domain-specific information and datasets, ultimately reducing hallucinations and improving the accuracy of responses. This innovative approach aims to enhance the capabilities of LLMs, allowing them to provide more reliable and accurate information. In the context of a RAG LLM, the vector database and retriever play crucial roles in encoding new information into a searchable database and determining the most relevant text chunks to a query. The LLM is not simultaneously aware of all information contained in the vector database, as opposed to its training data. Instead, it utilizes its knowledge base and learned capabilities for providing answers in natural language. New text chunks retrieved from the vector database are passed alongside the query to the context, making the embedding model, vector database, and retriever substantial components in the performance of a RAG LLM. The field of RAG LLMs is rapidly evolving, with new companies and products emerging and disappearing frequently. Currently, proprietary offerings for adopting a RAG LLM include options such as Microsoft's Copilot Pro, which costs $30 per user per month for businesses and can access documents stored in SharePoint. There are numerous products, companies, APIs, and libraries available for each component of a RAG LLM, including the embedding model. Implementing a Retrieval Augmented Generation, RAG, large language model, LLM, requires integrating multiple components, including the embedding model, vector database, and LLM itself. These components can be sourced from various providers, such as OpenAI, Pinecone, and Elasticsearch, which may necessitate coding and incur significant costs. Alternative options include user-friendly applications built on top of these APIs and services, offered by smaller companies, but this approach can lead to multiple cost-producing touchpoints. In contrast, the open-source landscape offers a range of free software solutions for building a RAG LLM. For instance, Hugging Face provides dozens of embedding models tuned for various use cases, while pgvector and ChromaDB offer open-source vector database solutions. Hundreds of LLMs are also available on Hugging Face. Frameworks like Flask and FastAPI can be used to create RESTful APIs, and front-end options include Streamlit and Gradio. Notable libraries for creating the final RAG pipeline include LangChain and Llama Index. One of the primary advantages of in-house development is cost-effectiveness. The cost of an in-house application is limited to the salary of the development staff and the cost of the machines where it is run, which can be either a one-time fixed cost or an ongoing service fee. This approach avoids the uncertain pricing environment of managed solutions, where costs can increase significantly with usage and user growth. For example, ChatGPT's estimated daily expenditure of $700,000 in 2023 directly correlates with usage and user growth, highlighting the cost benefits of in-house development. The implementation of AI solutions in RAG workflows faces challenges related to cost and flexibility. A key issue is the lack of a proven, long-lasting, profitable, and sustainable pricing model in the AI space, which introduces risks such as dependency on certain services that may experience large cost increases. Per-user pricing models like Microsoft Copilot Pro can be costly for large organizations. In contrast, hosting an application on a GPU-enabled Azure cloud machine supporting unlimited concurrent users is more cost-effective, with lower operating costs and greater flexibility. The institutional burden of getting new cost streams approved at large international organizations or NSOs can hinder the adoption of paid solutions. Relying on free, open-source software allows for development to be unconstrained by resources or bureaucracy, enabling the incorporation of the latest developments as they are released. This approach also provides greater flexibility in terms of features, as an in-house solution can be extended and improved on demand. For instance, Google's Gemini has been updated to introduce stronger censorship, illustrating the potential for closed-source offerings to be subject to change without input or agreement. The development of an in-house tool for generating reports from structured data, such as the RAG application, offers several benefits. Customization allows for tailoring the tool to fit the organization's unique requirements and workflows, reducing the risk of disruption and enabling a more streamlined and efficient reporting process. This leads to cost savings and increased productivity. Fostering institutional capacity is another significant benefit, as it enables the organization to gain valuable know-how and work with generative AI as an active developer. The development process yields byproducts like a vector database containing all of an organization's outputs, providing a deep understanding of how the technology works and enabling staff training. This knowledge can inform the organization's substantive work and expand the guidance and support it provides to developing countries on the topic of generative AI. Privacy and data control are also crucial advantages, ensuring that data is stored only where desired, particularly important when working with confidential or private data. The development of an in-house tool offers numerous benefits, including customization, fostering institutional capacity, and ensuring privacy and data control, contributing to enhanced report quality, streamlined workflows, and the accumulation of valuable knowledge and skills in generative AI. The ongoing debate between in-house development and external solutions for chatbot integration in international organizations and national statistical offices, NSOs, continues to highlight the potential risks associated with using external solutions. One of the major concerns is privacy, particularly with models like OpenAI's GPT-3, which poses risks of data breaches. In contrast, in-house development offers full control over data storage and security, mitigating these risks. However, in-house development also presents its own set of challenges. A significant concern is the availability of skilled staff to set up and develop such a system, as well as the need for ongoing maintenance and support. Another issue is scalability, where handling user growth from 10 to 100 or 10,000 users can be difficult without dedicated infrastructure and scaling expertise. Polish, robustness, and feature set are additional drawbacks of in-house development. Companies with large teams can create more robust and polished user interfaces, including aesthetics, design, and edge case handling. Furthermore, access to frontier models may be limited in in-house development, as state-of-the-art models are often closed source, leaving open-source models potentially behind in terms of power and performance. When developing a RAG application, organizations face a critical decision: whether to opt for an open-source, in-house solution or a paid solution. However, this dichotomy is not mutually exclusive, and organizations can choose a spectrum of options that combine elements from both ends, depending on their resources and needs. UNCTAD's in-house RAG application development experience provides a valuable case study. A key component of this development is a library that processes various document formats into raw text, enabling the addition of metadata information, statistical analysis, and topic modeling. This library is built around Llama Index, the primary tool for the RAG LLM, which is stored in a local PostgreSQL database. The database is made compatible with embeddings and vector search via pgvector. A separate library packages the final pipeline, making it LLM agnostic and accepting any LLM stored in gguf format, as well as embedding model agnostic. The user-facing front-end, written in Streamlit, allows for multiple simultaneous users and persistence of vector databases. This setup is designed to be accessible, with all three libraries available on GitHub and PyPI, along with Dockerfiles for easy deployment. The application's performance is robust, running well on NVIDIA GPU-enabled machines, Apple Silicon Macs, and even on CPU-only computers, albeit at a slower pace. Notably, the application supports unlimited simultaneous user sessions, with simultaneous generation requests queued and processed sequentially. This flexibility and scalability make it an attractive solution for organizations seeking to develop their own RAG applications. The development of the application, as depicted in Figure 1, highlights the importance of institutional space for pursuing innovative data products. Data science projects often struggle under traditional work programs and mandate structures, necessitating a flexible environment that fosters creativity and experimentation. The application was developed without a clear application or request in mind, yet it has shown potential for transformative impact across the organization's work. Its utility compounds over time, with the front-end interface being repurposed for other internal or external data products. This type of work is more akin to building a platform to enhance other work than producing an output in and of itself. The Global Crisis Response Group, GCRG, at UNCTAD enabled these innovations, not only around data products but also working methods, communication formats, and research approaches. With no legacy reports or work programs to fulfill, the GCRG's unique institutional setting allowed for the development of such novel ideas and methodologies. This underscores the significance of providing adequate space and support for innovative projects within institutions, which can lead to groundbreaking outcomes that transcend initial expectations. Investing in data science capacities and institutional space is crucial for successful projects that can serve as a compelling argument to the official statistics and international organization community. One potential approach for future work is fine-tuning an existing large language model, LLM, to enhance its performance in specific tasks or domains. This involves freezing most of the model's weights and training a small subset of layers, reducing computational and cost requirements compared to pre-training from scratch. Fine-tuning allows the LLM to maintain its knowledge base and sentence construction abilities while adapting to a particular task. For example, fine-tuning a model originally trained for text completion on question-response pairs can improve its performance with prompts in this style. While fine-tuning has been found less effective for specific fact retrieval than RAG in many instances, it has the advantage of making the LLM aware of a large corpus of information, rather than relying on the embedding model and vector search function. A potential solution is to combine both approaches, using RAG on a fine-tuned LLM. For instance, fine-tuning an LLM on the whole corpus of UNCTAD publications could specialize it on UNCTAD's positions, style, and body of work, then using RAG for direct information retrieval varying by the specific application. To facilitate local fine-tuning, the LLM fine-tune library was developed, accessible via Docker, utilizing the open-source unsloth package. This library enables local fine-tuning on corpora of raw text, without question and answer pairs, for knowledge and style injection. This approach can be particularly useful for institutional spaces with limited resources, allowing for more efficient and effective language model adaptation. Optimizing the RAG system is crucial for improvement, focusing on fine-tuning the embedding model and vector search functions to ensure the most relevant text chunks are passed to the large language model, LLM, for answers. Hyperparameter optimization is essential, involving the exploration of optimal chunk sizes, chunk overlap values, and context window sizes for various use cases. Introducing pre-filtering steps to the vector database can further enhance the system's performance by reducing the search space and increasing the likelihood of returning relevant chunks. For instance, pre-filtering documents by year can significantly shrink the search space and improve the accuracy of the results. The rollout, adoption, and training of LLMs are critical steps, particularly due to their natural language responses, which can appear omniscient and confident. Educating users about the limitations and validation guidelines of LLMs is essential to prevent hallucinations and incorrect information from entering official reports. The RAG system's design, which returns both the actual texts and metadata, facilitates the verification of LLM responses and detection of hallucinations. Generative AI offers significant promise for national statistical offices, NSOs, and international organizations, providing an opportunity to exercise agency and develop customized solutions that cater to their specific needs. UNCTAD's experience demonstrates that investing in data science capacity and institutional space can lead to the development of generative AI applications entirely in-house and at no cost. By leveraging open-source resources and communities, NSOs and international organizations can harness the potential of generative AI to drive innovation and improvement. The developed infrastructure and acquired institutional knowledge offer flexibility and potential for future directions. The current setup can be adapted to incorporate paid components or transition to a fully managed solution, such as replacing the local open-source language model with an OpenAI API call. This would eliminate the need for GPU-equipped machine hosting, address scalability issues, and provide access to frontier models without incurring costs for the vector database or embedding model. The in-house skill development enables flexibility in solution choice, allowing for adaptability in response to changing requirements. By sharing UNCTAD's experience and contributing to the open-source community around generative AI, the authors aim to lower the barrier to entry for national statistical offices and international organizations in developing their own solutions. This highlights the importance of collaboration and knowledge sharing in advancing AI technology adoption within these organizations. The project serves as a case study on leveraging cutting-edge AI technologies to improve document similarity analysis at minimal cost. By demonstrating the feasibility of this approach, the authors hope to inspire other organizations to explore similar methods, ultimately enhancing the efficiency and effectiveness of their operations.